Good evening. Thank you so much for joining us. Tonight, our CPD session is in science, and we are delighted to welcome Neil Ingram of Bristol University. He is our team leader for science, and having heard some of his CPD before, I'm really excited to hear everything he has to say this evening. He's brilliant. Joining Neil are Ian Lovett and Barry Wilde, lately of Ampleforth College and Cheltenham College respectively. Neil heads up the biology team, Ian the physics team, and Barry the chemistry team. So we have everybody with us tonight to answer your questions. The aim of these sessions is to support you in delivering the new specifications for CE. And this session tonight is going to focus on answering all those questions you've been sending us about the new CE science specification. Neil, Barry and Ian are also going to be covering teaching and revision techniques and some general tips and tricks from our experts about getting the best out of the new specifications in science. Our aim at ISEB is to improve our assessments at every opportunity. So we'll also be covering how to encourage thinking and working as a scientist in not only yourself, but in your pupils in our next session, which will be with Neil Ingram as well. Make sure you sign up on Eventbrite for that session. That will be on June the 25th, and there's currently an early bird discount if you book soon. So we'd love to see you again, and I'm sure once you've heard the team today and gathered what a wealth of knowledge they have, it will be great to move on and see what else is there in the specification in June. Another reminder is that ISEB has gone digital, and so you can catch us on social media at ISEB Awards on all channels. We'd love to see you there. Please come and be our friend. And now, once this session has finished, there will be some more time for questions, although this session has been built on all of your questions from the start. But you can use the chat to pose questions at any time, and you'll see I've already put a couple of comments in there. If you are struggling to access the chat, please remember you have to log in. So if you log in to either Google or to YouTube, suddenly that chat function will work if you've been having some problems with it. I will make a note of your questions as we go along, and then I will pose those to the team once we get towards the end of Neil's presentation. However, I know you're going to have a great time. All of this session has been built on what teachers have asked us to cover. So it's very much a crowdsourced session this evening, which is fantastic. But without much further ado, I'm now going to hand you over to Neil, Ian and Barry.
Thank you very much, Julia. Okay, let's get going then. We play the slides then, please. Welcome, Ian. And Barry's there too. Okay, as Julia said, we're really here to answer questions that you have either submitted in advance or during the course of the evening, and we're going to touch on quite a number of themes tonight, rather quickly, but we will cover quite a lot. And if anything inspires you to ask a question, then do bang it into the chat and we'll try and answer it at the end. Okay, next slide then, please. Right, the first question that we're always asked is, are there any CPD resources available? And the answer is that yes, that if you go onto the ISEB website and go to examinations and assessment, there's a list of things that you can get there. You can see it on the screen, and the bottom one is science topic resources. So if you download that link, next slide, please. You can see some of the resources that we've already created. Now, I should say that these resources have been created directly as a response to feedback from teachers like yourselves. We've been talking with teachers as they've written in over the last 6 to 9 months. And whenever we've had a question, we've tried to address it in a series of rather short, almost like notebook worksheets. And we're happy to produce some more of those. If you yourselves are interested, then just ask for particular topics. The one that I think is particularly important is the one on energy, because the only real new thing that's come into science at 13 plus is the way in which we treat energy transfers, and that is now consistent with the Key Stage 3 national curriculum. And this is also consistent with the approach taken at GCSE. And I thought I would just begin by sharing some CPD that I did last week with the question setters for science. So you can see the kind of things that we're saying to the people who are actually writing the questions. So if we can have the next slide, please. Oh yeah, before I do that, if you want any particular resources, then do ask. For example, somebody's already asked for one about food tests. We could do a little sheet about that. One possibility might be to do something with maths. Mathematics, to see whether we can produce something on graph plotting and general mathematical skills, but that would be a rather more extensive resource. But these are the kind of ideas that we're thinking about. Okay, next slide then, please. Okay, next slide then, please. Next slide then, please. Here we go. Right. This is what I said to the examiners last week. Forms of energy that we used to talk about: heat energy, chemical energy, light energy, electrical energy, potential energy, we can no longer use. That model of energy is no longer being taught at Key Stage 3. It's been replaced by the idea of energy being transferred from one store to another. So if you have the next slide, please. We can talk about stores of energy, thermal stores of energy, chemical stores of energy, elastic stores of energy, nuclear stores of energy, kinetic stores of energy, gravitational stores of energy. All of those are acceptable terms. Next slide, please. So we're talking about energy being transferred between stores along what's called pathways. And at 13 plus, we're going to use the following pathways. Mechanical pathways, that's a force acting over a distance. Electrical pathways, that's electric current. Heating, due to a temperature difference between two places. Radiation, electromagnetic waves, and chemical reactions. Those are pathways along which energy can be transferred. Next slide, please. Now, this causes real problems because we use words like light in everyday speech in lots of other contexts when we're not really talking about energy transfers. So we can still talk about light as a thing that can be observed. Light is shining through a window. It's perfectly fine. Light, when we're talking about energy transfers, is a specific example of the radiation pathway. Energy is transferred from the sun to the plant by light is okay, because light is referring to the pathway along which energy is being transferred. What we cannot say is chlorophyll absorbs light energy, because we cannot talk about forms of energy like light energy. We can say that chlorophyll absorbs energy from the sun. Now, all of this is discussed in the resource paper that you can download from the ISEB website, as we've already discussed, and it is something that will occupy us in more detail in our second ISEB presentation later in the year. Okay, next slide then, please. So here's a classic diagram that everybody starts talking about when they first start doing science. We no longer will be able to talk about heat as a noun. Heat isn't a thing, it's a process. It's a way by which energy is being transferred. So instead of putting heat on the Bunsen burner, we're going to put heating to show that energy is being transferred from the Bunsen burner to the evaporating basin, or to the substances in the evaporating basin, more to the point. So heat as a noun is something that we would really ask you to try not to use. Now, the students will find this easier than the teachers, I'm sure. But nonetheless, it is the approach that's being adopted and supported by the Institute of Physics for teaching energy at this level in schools. Okay, next slide then, please. So just to go back to photosynthesis then, we cannot talk about chlorophyll capturing light energy. We cannot say that light energy from the sun causes photosynthesis. Both of those are talking about light as a form of energy. We can say sunlight shines on a plant. We can say, if we wanted to be formal about it, energy is transferred from the sun to the plant along the light pathway. We can say that energy is transferred from the sun to the path by light. We can say that photosynthesis is a chemical reaction pathway. Okay, next slide then, please. Likewise, respiration, those are old diagrams, equations, where they're not really chemical equations. They're more descriptions of the reactants and the products, of course. But in the days when we used to put glucose plus oxygen gives carbon dioxide plus water plus energy, I don't think we can really be consistently do that anymore. So what I'm suggesting is maybe we can do it as a two-stage process, put the reactants and the products on the one line. And then if we want to talk about energy transfers, we can talk about the energy storing glucose. Energy is being transferred to the energy stores of the body. And at the same time, some of the energy is transferred to the environment, to the thermal store. And that is an alternative way of saying it gives out heat, because we can no longer say it gives out heat. We can say that energy from respiration warms the environment, but we cannot say heat. Okay, next slide, please. Another area that's come in at Key Stage 3 and GCSE is part of thinking and working of scientists, and that is the idea of accuracy and precision. And again, we've written a briefing paper about this as well. The key idea here is that precise measurements are close together, but they may not be accurate. So, for example, if I give you a ruler and ask you to, and I've taken the first 10 centimeters off that ruler, I've sawn it off, and get you to measure the heights of all the people in the room, you will have precise measurements, but they're not necessarily accurate because of inherent problems with the measuring device. And that's the point that they're trying to get over. And one of the analogies that they're using is that of a dartboard. So, for example, if the true value of the result is in the center of the dartboard, then the first dartboard there, where all the darts are really in the bullseye, the results are both accurate and precise. The second diagram on the right, top right, they're accurate because they're still in the bullseye zone, but they're spread out, they're not precise. In the lower diagram left-hand side, when they're in the blue, they're neither accurate nor precise. Sorry, they're not accurate, but they are precise because they're clustered closely together. And then finally, in the bottom right, they're not accurate or precise. So those are the kind of analogies that people are using to begin to think about the differences in terms. Okay, next slide then, please. Another word that's come in, and again, all of this has come out of the Association of Science Education, thinking about the language of measurements. Valid, the term valid measurements are those which measure what they're supposed to measure. They don't have any inherent error built into them. And then the term repeatable means that the same group of people get similar results when they repeat the experiment. If a group on the other side of the room or on the other side of the world, or people on the other side of the world using a different technique get the same results, then they're said to be reproducible. So repeatable means repeatable by the people collecting the data. Reproducible means that they are repeatable by other people in other groups. And again, that is a sort of semantic distinction, but nonetheless, it is one that's coming in both at Key Stage 3 and also at GCSE. Okay, next slide then, please. So, for example, this is meant to represent a clinical thermometer. and the person has a body temperature of 37 degrees, was right in the middle of the center of the scale. And the question is, the class results are accurate and precise. Which one of the following 4 options shows results which are accurate and precise if the body temperature is 37 degrees? And of course, if you look down, it's D. In D, it's the only one where the results are clustered closely together and also close to the true value. So I gave that to the examiners as a way of trying to think how we might ask questions about this. We'll see whether or not they come up with anything in years to come. Okay, next slide, please. So the first one then, just giving you the answers, the true values in the middle, as I say, 37. The first set, A, they're precise, they're clustered together, but they're not accurate, they're not close to the true value. The second one is that they're close to the true value, but they're all spread out, they're not precise. The third one, C, they're neither accurate nor precise, they're all over the place. And as I say, D, they're both accurate and precise. Okay, next slide then, please. Now, here's a standard set of questions that the teachers are asking. The reactivity series has gone. Replace reactivity series with whatever your favorite bit of the specification is that's no longer there, the digestive system or something. Somebody said to me that their favorite part of the common entrance syllabus was stem cells. Well, stem cells has never been on the common entrance syllabus, so I don't quite know how that is a favorite bit, but imagine the reactivity series has gone. Does that mean that we should still teach it? It was my favorite part. The students love it. Well, the answer is well, no, and yes. The point of the new specification revision was to reduce the amount of time for the prescribed content, to allow you as schools and centres to develop your own science curriculum, of which the common entrance specification is but of a part. So therefore, if you think that reactivity series is an important part of your teaching because it helps to develop practical skills, it helps to develop analytical skills, and it helps to develop deductive skills, all of which are valuable scientific skills, then if you've got time to put it in, then put it in. However, there will not be a specific question in the examination about reactivity series. And when we go through the papers, as indeed we did last week and we will do again, one of the things that we're looking at is it on the specification? And if it's not on the specification, i.e. explicitly mentioned in the specification, then we don't put it in. And it's that is the rule of thumb. And we are more conservative about that than ever. So the idea was, oh, well, we've always taught it. It doesn't count anymore. It has to be specifically named. The idea of reactivity series could be examined, but we would give the students enough information in the question to be able to answer it, even if they hadn't studied reactivity series. So I can't imagine what a question would look like on that. But the idea is that we're giving support to students if they haven't covered that particular bit. And in fact, we probably wouldn't ask reactivity series because it is a rather specific part of the course. Okay, next question then, please. So I've done that. I've addressed that particular question. Next slide, please. Thinking and working of scientists is something that schools have asked for. They've asked for more time to develop their own practical courses. And thinking and working as a scientist is based very heavily upon what's in Key Stage 3, working scientifically. That is intentional. We didn't want to reinvent the wheel, but we did see that is part of the kind of science that you would probably want to develop in your schools. Now, we haven't changed the assessment model. We haven't increased the amount of time for thinking and working scientist. We haven't increased the mark allocation for that. We haven't changed the exams at all in this particular revision. What we've done is created space to allow you to develop, hopefully over the next few years, and it will take a few years, your own science courses. Now, in the summer, when we meet again, then that's something that we can discuss in more detail. So the thinking and working as scientist ideas that you want to try and incorporate into your schemes of work go under the headings of modeling scientific attitudes, developing experimental skills, devising and carrying out investigations, analysis, and so on. Okay, next slide then, please. How long should we spend on thinking and working as a scientist? Well, the answer is it depends how much time you are spending teaching this prescribed content. We have removed a number of topics. This was very painful to us, but we have. We have thinned out within a topic some of the statements that we were asking. So hopefully we have created time for thinking and working as a scientist, but there's no definitive answer to how long you should spend on that. It's whatever you as a science department feels is important when you've covered what will be in the exam. Now, we took the tentative step of just mentioning a few suggested practicals in the spec. Those aren't compulsory, but they are the kind of ideas that we might want to examine. Hence food tests, for example. And again, there probably will be the things that will be supported by these teacher resources that we are planning. Incidentally, you don't have to do the practicals as student-based practicals. You can do them as demonstrations, and there's also lots and lots of good video channels now where professional videos are being produced on practicals. One of my favorites, because it's a local school to me, we work with them on the Bristol PGCE course, is Malmesbury School, and I know they're aiming really at GCSE and A level, but there are some videos. For example, there's one very good one on using microscopes, which you might want to use and share with your students. So the Malmesbury School YouTube channel is one that I would heartily recommend, and they produce really good quality videos, but there are lots of other places too. Okay, next slide then, please. Food tests is an example of one that that's just a screen capture from the video showing the kind of things that they're talking about, and that video there on food tests is very much the kind of things you could use with your students, either getting them to look at the video in advance so that they know what they're going to do when they come in. That will save you having to explain it again. You will still explain it, but it should be easier for them to understand it, or they can review it afterwards, and so on and so forth, or they can even use it for revision. So next slide then, please. The summer session then is on the 16th of June, and we're going to do two things on that. We're going to look at energy in more detail, following the paper that we've produced that's on the resources on the website, and also we're going to have a look how you plan thinking and working as a scientist, not as across the curriculum. How do you embed that over your science program? We're going to look at that from the point of view as a head of biology. Okay, next question. Now, one of the questions that we asked was, is the 11 plus syllabus going to be revised? We have no immediate plans to do that. I think one set of changes is enough to embed in a school at any moment in time, but doubtless at some point Julie will want to have the 11 plus specifications revised across the whole suite of subjects, and that would be the point in which to do that. Okay, next slide. Ooh. One of the questions was distant time graphs. Should they be included or not? Our feeling is, although they're not specifically mentioned in the left-hand column, they are a very good way of teaching the spec point that says speed is measured in a variety of units. But that is always the distance covered in a given time, meters per second. And therefore doing that as a graph, particularly as a practical activity, is really quite a good way of doing that. So we would encourage that as you exploring that as a way of teaching that particular spec point. Okay, next slide then, please. We haven't created teaching topics of standard length. Some will take longer than others. You may want to expand some topics to fit in with your own departmental interests, for example, ecology. You might want to reduce some. So the answer is, on average, we think a notional 1 week plus prep time for each of those syllabus units is probably about right. And the syllabus units, of course, consists of, a number of different spec points. Okay, next question, next slide, please. Should we teach more? Should we be teaching the additional content in year 9 that isn't actually covered in common entrance? Well, I think my personal view is that you probably shouldn't. Many of the senior schools that I'm encountering, and indeed many of the state schools that I work with too, are starting their GCSE courses in year 9, probably in the second term. And therefore, a lot of what would be in the year 9 Key Stage 3 gets taught as part of that. So there probably isn't any need to front load that in year 8. At least that's my private view. Next slide, please. Do we recommend that they teach the sciences separately, or are they core themes? And again, I think that depends upon the tradition of the science department. Some organize things one way, some organize things the other way, some integrate them, some don't. I really think it doesn't matter. I think it all depends upon the expertise of your staff and the way in which they like to work. Next slide, please. When planning my schemes of work, what topics do you prioritize in year 1 or year 2? I don't know, to be honest. We haven't designed a teaching scheme. That was never our brief. That was never our intention. But I do think it's something that actually there is value in talking about, and it may well be, and I think I'm kind of blue skying a little bit here, some form of kind of sharing of ideas between schools who are teaching this course. Suggestions for good practice is something that we would probably want to try and facilitate. So that's something we'll go away and think about, whether we can set up a forum by which maybe you can share these ideas across different schools. Because I am well aware that if you're working in isolation in a prep school and you perhaps haven't got contact with support groups, then some form of forum like that might actually be of value. Next slide, please. Would you recommend a pupil takes the foundation paper or the core papers? Well, I think the first thing to say is we really like the foundation papers. We were given the brief of trying to reduce the amount of time for examining, reduce the simplicity of the complexity of some of the language in the questions without simplifying the science. And I think we try very hard to be able to do that. But we also recognise that the decision of whether somebody should do foundation or higher tier, to some extent, depends upon the school, the preferences of the senior school that they're aiming for. And indeed, so there's lots of other social factors as well as that. But obviously, we do think that the foundation papers have a value in their own right. So therefore, and of course they are a useful. The foundation papers are not the same as 13. As the L2 papers. So therefore they are an additional source of questions which might be of value to the department. There are differences between them. For example, we always include the formulae on foundation papers, and sometimes we do and sometimes we don't on the higher papers. Okay, next question then, please. Choice of textbooks. I am aware from correspondence that I've read with schools that actually budgets are tight, and that actually you may not want to change your textbooks. The Galore Park textbooks have been revised in the light of this specification, but you may want to continue to use the old ones. I think that is okay. With the proviso is that there's a lot of talk about forms of energy in the existing textbooks that we won't be examining, and also there's a lot of material in the Galore Park books, both the previous ones and the new ones, which are not on common entrance because they're covering Key Stage 3 as well. So you'll have to train your students to say because it's in the textbook doesn't necessarily mean that it's in the exam. Okay, next question then, please. We love the idea of bringing science to life, and I wonder if you had any good up-to-date suggestions about school trips. Well, we don't really, but again, if we set up some kind of forum, then that would be a good thread for a discussion on that. Next question. Next slide, please. We've offered guidance for summer 2022. Make sure that you've received it. To be honest with you, I don't think I can go further than what we've said in that. We've tried to be as helpful and specific as we can be. I think if I gave you any more clues, then it was probably unfair to people who aren't here. So we'll leave it at that. Say, yeah, to make sure that you've got that and that you look at it. And we've tried to be helpful with that. Okay, next slide, please. We have assessed not only the knowledge, and we've also addressed the TWAS skills that will be assessed as well. Next slide, please. Just to finish with them, just to remind you that the examination questions are set against assessment objectives, remembering and understanding, applying and analysing, evaluating and creating. Next question, please. Next slide. I mean, some questions, particularly in question 1, have very little or no context. And one of the things that we're trying to do and move towards is perhaps giving more context in those questions. So, for example, I've made these questions up. They're not questions that would ever appear in the exam, but I've just made them up to show you what I mean. The colour of apples is black, red, purple, or white. Might be a kind of question 1 that appears in the multiple choice papers. Next slide, please. To provide more context to that, we cannot assume that students necessarily know what an apple is. So we would put a context in, maybe a photograph or a diagram, particularly in biology where we might be talking about parts of the body. We might be putting a diagram in with labeled parts in it. Apples are flowers, fruits, stems, or roots. So we're trying to add a little bit more context to those kinds of questions. Next slide, please. Multiple choice items, we're beginning to embed them throughout the paper, not just in question 1. And we've done that in response to schools that have said that there's too much writing, particularly in the biology paper. So we're where there is, we're beginning to use multiple choice items to reduce the amount of simple writing that students have to do. We haven't changed the style of the questions, but we're just simply hopefully making it easy for the candidates to answer in the time. Next slide, please. In the past, you've provided a formula sheet in the exam. Will the exams new spec do the same? No, I don't think they will necessarily. As I say, on L1, we do give the formulae. On L2, we sometimes do and we sometimes don't. Some standard formulae we would expect students to be able to do, but very often we give the units for the calculation that we're looking for, and that gives a very good clue as to what the formula might be. So one of the things that we suggest you do is you train the students to look to see what the units are and see if they can work out, if they don't know the formula, what the formula might be. That's fairly standard at GCSE as well. Next slide, please. There seems to be some disparity between the way graphs are taught in maths and science. That may well be the case, and this is something that I think we would want to have a look at, and again, produce a briefing sheet in due course. But we're grateful to you for pointing that out to us, and we will try and talk to our maths colleagues and see if we can produce some kind of agreed approach. Okay, next slide, please. Chromatography. Here's an example of where user feedback from schools has actually been really useful. Somebody said when including chromatograms in the exam paper, it is usual practice in the second diagram to leave a lighter spot on the origin to show where the chromatogram started. And they've noted that some of their pupils are interpreting this as an indication that there might be more than one dye in the substance and that one of them is insoluble. We've taken that on board. If somebody put that in an exam, that would be a very mark-worthy point, of course, and that's something that we try and build a certain amount of flexibility in our marking schemes. But we will ensure that the origin spot is clearly labelled in the future, so that hopefully won't arise again. So we're grateful for that feedback because it's helped us to tighten up those style of questions. Next question. Oh yeah, one other final. I've reached the last slide. You'll be relieved to know I've reached the last slide. One of the things we hope we'll do in the medium term as a result of this specification revision is to give you space to be more creative and to be able to share good practice. And one of the things that you might be interested in promoting is the idea of literacy as well as scientific literacy in your students. And this is a side project of my own, which gives you a kind of example of the kind of things I'm talking about. I've got a blog. It's really aimed at literacy at years 6, 7, and 8, really. And it's called Stories from Nowhere, and it's about what happens in a wood. You can't see out my window. There's a wood called Nowhere Wood. It genuinely is called that. And me wandering around Nowhere Wood has resulted in me writing a blog about the changes that are occurring in that wood and linking it to the big ideas of biology thinking. And their little stories are only about 300 words long, if that. And they have an online glossary designed to promote children's reading and children's curiosity about the natural world. And they're meant to be free from specifications. They're not meant to be studied or learned. They're just meant to be read and enjoyed. Now, again, if you're interested in that, the URL is storiesfromnowhere.co.uk. If you're interested in that as a concept, then get in touch with me, because I'm quite keen to talk to some teachers who might be interested in working with me on that to see if we can create some new stories. But there's an example of a project. It doesn't have to be from me. It could be from any of you. A good idea worked up that we can share within the community. Sounds to me like definitely worth encouraging. Right, I think that's my last slide. So let's open up to questions then.
Thank you so much, Neil. I have got just a couple of comments, but I wondered actually if you wanted to come back on those. From Mr. Busfield, he did say these forms of energy do still exist. That's very true. But he says, aren't we supposed to be Key Stage 3 plus? And I thought, you know what, that's a really good question. We should ask that.
Well, it depends what you mean by plus, doesn't it? If by plus you mean additional knowledge and content, then no, I don't think that is not really where we're heading. I think if we're talking about plus in terms of experiences, understanding practical activities, going out on field trips, getting students to do different kinds of writing, then yes, that's a plus. So I think 13 plus, we are still loosely tied to Key Stage 3, but I have to say that because of the content reduction we've done, we're not as tightly tied to Key Stage 3 as we were in the previous iteration of the spec.
Thank you very much.
And guys, you want to make any comments? Do feel free to chip in with these comments, Barry and Ian. Okay.
So the next question, something's just come in from David Luard, who I believe I've spoken to online. Hi, David. Good to see you. He said the spring 2022 chromatogram spots were not level, which was quite confusing for pupils.
I haven't got the paper in front of me, but I think this was the paper which the chromatography question came in about, actually, that we replied to.
Yeah, we've already agreed that that actually we found that a very helpful comment. We hadn't appreciated it. We're grateful for the comment, and we're going to make sure that we make it easier next time. So yes, that's one of the values of these kind of constructive feedback is really valuable. You'll be surprised how little we get, and therefore it is always valuable when something like that is said. So thank you very much for that, Chris.
Yes, I did a survey of all the AQA and other board GCSE papers to see what their practice was, and they're all different. But we'll devise a way to make it absolutely clear.
We'll devise a way to make it clear, and we'll then consistently use that method. I think that's the key thing. Whatever it will be, will always be the same.
Lovely.
But I think Neil's point about the mark schemes is that it isn't definitive, that it's up to the teachers to actually decide. You know, if a candidate is sensible, then they should be given the credit for it.
Lovely. Well, we have lots of questions that have been coming in over the last couple of weeks. I know somebody's just said, I sent a question and it's not been asked. Please don't worry. What we've done is hold some of them back so that we can do a Q&A with the wider team as well. So the first of those that had come in says, I would love to know some effective ways to include more EDI within the science lessons in with the curriculum. So do you have any ideas?
Sorry, Julia, you broke up on me then. More what?
Some effective ways to include more EDI, so equity, diversity and inclusion into that science curriculum.
Well, one of the things that we've been thinking about, and indeed we've produced a poster about, is significant women in science. So there's one example of that. I think we do try in our questions to write questions which are balanced and you know, non-gender specific and as diverse as we can. We do ask questions from all around the world, for example. So the answer is I think develop that along. I mean, talking about important scientists seems to be a really good way of being inclusive here, and you know, all sorts of different scientists. And I think, you know, neurodiverse and you know, that would be the way I would suggest you do it.
Yeah, lovely. And actually, we do have some resources that the team has been creating that will be forthcoming from science, and they've done some lovely resources about female scientists and female scientists as well, from all over the world. So that's a great thing that we'd love you to watch out for. Another question that had come in earlier says, I have noted that the current curriculum my school uses is very heavy on the pupils. Is it advisable to just follow the bare ISEB curriculum and remove all non-examinable aspects from our school curriculum? So I think this is really coming in on something you discussed earlier, Neil, which was balancing PE with other curricula.
I think the answer to the question is that in response to the widespread concern amongst schools that the existing form of CE was too content heavy, we've reduced that to allow schools to diversify and develop a curriculum that they feel suits their particular local needs and the needs of their secondary schools. And therefore the answer to the question is, you do, as long as you cover what's in the CE spec, that will be what is examined, and then the rest of it is up to you.
Lovely. Excellent. Well, here's a very broad question, but actually it might be really useful perhaps if each of you with each of your science disciplines could take a part of it, which is what exactly has changed?
Well, in chemistry, we have removed a very large topic, which was the reactivity series of metals, and you know, that was really quite a large chunk we removed, which we think was the right thing to do. And the other thing we removed actually was the temperature dependence of solubility graphs, So there was quite a large chunk of material was actually gone from the chemistry section.
Lovely.
Yeah, so in terms of physics, we've taken out moment completely. That's gone and that was a relatively large topic. We've slimmed down the electricity section as well to make it so taking out things like truth tables from the electricity section, circuit section. A lot of what was done in the electricity section is covered in 11 covered earlier on key stage 2, and so we've simplified that to avoid repeating stuff that had already been covered. But the largest part we've taken out is moments.
I think in the biology we have cut some topics out. I can't just for the moment remember what they are, but we've also slimmed down what was in the right-hand column of the old spec quite significantly, and so quite a lot. And we've removed some of the spec points from each of the areas as well. But we have produced a list of the changes, so it should be on the ISEB website, so you can track it in detail. But we do feel that we have, I mean, this isn't just tokenism. We genuinely feel we've taken quite a lot out, really.
Lovely, thank you. We've had one in from George Radcliffe. He says, the recent particle question on tungsten bulbs was quite challenging. Shall we expect more like this in the future?
I think that was in a chemistry question where it was the filament was actually evaporating and going on. It is quite a difficult question, but I think on a common entrance paper, ought to have one or two questions which are quite challenging, because there are people doing common entrance who could do scholarship, so that there aren't many of those. But I think we do actually include some quite there, and it probably wasn't for many marks, I don't think.
I think as a principle, we are not changing the difficulty of the paper. We're not as principals only going to set hard questions or anything like that. We're trying quite hard, as Barry says, to give a range of questions, but actually some of them will have some teeth in them. That is what common entrance is respected for. But that equally, hopefully they will be balanced by other questions which are slightly more straightforward.
Excellent. So I've got one of two parts here. It says, what is considered better or advisable best practice? A, pupils taking notes in class after learning, or B, a booklet on the teacher's notes where pupils just fill and tackle challenges but not officially take notes?
That is a fascinating question. I sit in, I would say, about 150 lessons a year across 30 or 40 different schools, mostly at Key Stage 3. And I would say the practice is changing. A few years ago, booklets were all the rage. But they're booklets that the students have to write in rather than simply, read. There has been an increasing move back to a more traditional pedagogy in quite a lot of state academies, where they are literally writing in exercise books as they go along, which is what happened in a lesson I saw today. So the answer is I'm not sure. I think it comes down to whatever the sort of zeitgeist is in your school, really. That there will be people who are thinking about teaching and learning at a higher level, I guess, and you fit in with that. But I would have thought a mixture of the two is probably somewhere. I used to like a variety of approaches. I don't know what Barry and Ian used to like.
Yeah, I would agree. A variety. I used to do. I certainly, and lessons I've seen recently, it's a combination of both.
Yes, I find a combination of both is best, really. I do a bit of tutoring with some students now, some A-level, and there's a local school in Cheltenham that does everything in booklets, and I find that's a bit sterile, to be honest, them all doing that. I think a mixture is best.
Lovely. We have another question here, which says, what do you mean by calculate the magnification of a light microscope? I interpret this as magnification equals image size divided by actual size, or will candidates need to measure scales and actual sizes of images on the paper? Really good question, Neil.
Oh, that's a brilliant question. I interpret it as being the magnification of the microscope is the magnification of the eyepiece times the magnification of the objective lens. We've asked that question before. I think if we were going to do what the question asker is wanting, where you actually have a picture of a cell and you measure it and then you calculate its actual magnification. I think we could do that. It fits well within TWAS. I would almost certainly have a start and end point on the diagram so that they measured the length of the line rather than the width of the cell. That is standard practice now at A level. And I think if I was going to do that, I would give the formula in the question. In fact, I'm sure I would give the formula in the question so that they weren't expected to remember it. Then it becomes a TWAS question where they're simply using information to produce an answer. So the answer is it's not off limits, but it will be structured in that kind of way.
Lovely.
Good question. I hadn't thought of that.
Yeah, very good. And just for anybody out there, TWAS is the thinking and working as a scientist.
Yeah, sorry, it's an acronym valley. Yeah, my apologies for that.
No, it's a lovely part of the new syllabus. So it's always good to be able to mention it more whenever we can. I have another question here. The recent focus on practical tests has drawbacks. It disadvantages children who learn remotely or who miss practicals through mitigating circumstances. Could you explain your rationale for this? So something around a focus on practical sessions for children and what happens if they've missed some? What happens if it took place a long time ago and that might be the only time they cover that?
Okay, shall I take this one? I think I've got a lot of sympathy with the question asker for that, and if the question asker, the person asking the question, would like to contact me, I'd have a further discussion on this. What we try very hard to do, and this is true across all of our papers, is to have those kind of practical questions that you should be able to do by using the information in the question, because they're built on a series of rather simpler skills. So the assumption is you haven't done that practical, but you should be able to work out how it works just by reading and looking at the diagrams and the information and the data. So therefore, that's how we get around the fact that we're not prescribing core practicals. Now, I think that is something that we hope works. It's what we've been doing for a long time. It's not a new policy, and we've not changed it in any way. So therefore, I hope that will be okay. Now, if the question setter feels that it's unfair, and I've got a lot of respect for that view, then let's see if we can have a conversation, see if we can make it fairer. But for now, I think that's where we are on this.
Thank you very much. So I've just put a further call out there for any questions at all. We've got Barry, we've got Ian, and we've got Neil. So do ask any discipline-specific questions. But what we do have here is a really lovely question, and it's one for each of you, actually. Somebody's come in and said, in each of your fields, which topics do you find people are most engaged with? So pupils of your age or the CE age, what are the topics that you guys find are the most popular, or the favourite ones that children engage with? Why don't we start with Ian, because he's got a lovely big smile.
Right. Well, I would say straight away space, the space topic. I think you can expand that one as much as you feel you want, and I think you always find the children are really engaged and excited about that. That is why, for one reason, why that was definitely one part of the specification that I wasn't into. take out.
And if you look at the transition of questions from 11 plus through Foundation, L2 case on space, and Ian likes writing questions on space, so there's always lots of questions on space. You can actually see a progression in complexity, which I think is what we're hoping for, that's what we're aiming for. So yeah, space, I would agree with that.
Yeah, that's definitely my favorite too. I love those questions on space. So yes, brilliant. How about in chemistry? Which are those favorite topics?
I think it's the chemical reactions, really. I think it's the sort of spectacular demonstrations that you can do, things on combustion or and the experiments that pupils can do themselves and see all the color changes. I think that's what really promotes enthusiasm for the subject.
Yes, definitely. The ones I hear about from my daughters when they come home from school is anytime they've done anything with magnesium, we know about it. So, yes, I think definitely the bangs and the flashes are a huge favorite and talked about a lot. And so let's end on biology. Favorite topic?
Well, if I can just answer I mean, having looked at students doing practical work in my lessons I observed, of course, practical work went into abeyance during 2020 and to some extent 2021. Chromatography seems to be, they do love doing chromatography of inks and Smarties and things, but biology, I think they like going outside. I think they like ecology. I think they like, and that's one of the reasons I set up Stories from Nowhere, because it's about whole organisms living together in a wood. I think that's an area that students like. But another area that I think students are increasingly interested in is this whole idea of renewable energy. And climate change and all of that, and that kind of cuts across all three of the sciences, really.
Absolutely. I think it's not only such a hot topic, but I think children are so engaged with it, aren't they? So yeah, absolutely. So thank you all three of you for joining us this evening. We've had some brilliant questions, wonderfully fielded by all of you. And, you know, with science being such a huge core subject for everybody, it's just great to have the three of you on screen talking about CE. We're really looking forward to your session next time as well, Neil. We'll be talking a lot more about thinking and working as a scientist. But in the meantime, thank you so much, Barry. Thank you, Ian. It's always lovely to see you, and it's always lovely to hear you as well. To all three of you, a huge thanks. Neil, I wondered if you could just give us the URL. I was going to put that into the chat where you wanted teachers to contact you. Oh, why not?
It's www.storiesfromnowhere, one string, .co.uk.
Lovely.
And again, I genuinely am interested. I mean, you can write and say it's awful, or you can write and say it's really interesting, or something in between. I'm just genuinely interested in getting feedback, because no one's ever tried doing this before, and I think it's an interesting idea.
I do too. Well, that has gone up there onto the chat for you, Neil. So please, everybody, do get in touch. We would love to see you all again in June. So do remember there's that early bird discount on Eventbrite, and we will be talking about all sorts of things, not least thinking and working as a scientist. And please keep your feedback coming in. As Neil said, as the whole team has said, when you give us these comments, we go back, we look, we're constantly trying to make things better. And the team are hugely enthusiastic about all of these subjects and making wonderful exam papers. So do keep talking to us, whether that's through our inquiries at iseb.co.uk or posing some more questions for us ahead of the next session. But I shall let you all go off and enjoy your tea now, 1801. And thank you so much, everybody, for joining us, and to our wonderful speakers. We really look forward to seeing you all again soon. Thank you, Miss Shah. Miss Shah found it very helpful, guys. So thank you.